The order of existence between black holes and galaxies has been a subject of inquiry. Did black holes precede galaxies or vice versa? Recent discoveries have completely upended our understanding of how galaxies form, causing a significant shift in our perspective. Greetings to everyone. Today's video focuses on recent discoveries that propose a significant role of black holes in the early development of galaxies within the first 50 million years of the universe. This challenges the traditional belief that black holes formed after the emergence of the first stars and galaxies. The findings, published in the astrophysical journal Letters, suggest a coexistence and mutual influence between black holes and galaxies during the initial 100 million years of the universe. The researchers anticipate two distinct phases in the early universe, with black holes driving star formation through high-speed outflows in the first phase, followed by a slowdown in the second phase. Without further delay, let's begin our discussion. The conventional understanding that black holes came into existence after the emergence of the first stars and galaxies is being challenged by groundbreaking insights. These insights completely overturn theories about how black holes influence the structure of the cosmos. It is now suggested that black holes may have played a significant role in expediting the formation of new stars during a brief 50 million year phase in the universe's vast 13.8 billion year timeline. Lead author Joseph Silk, a professor of physics and astronomy at Johns Hopkins University and Institute of Astrophysics Paris, Sorbonne University, expressed astonishment at the discovery that monster black holes not only exist at the centers of galaxies near our Milky Way, but also were present at the very beginning of the universe. These black holes served as fundamental components or origins for early galaxies, resembling building blocks or seeds. In a remarkable twist of expectations, they acted as immense amplifiers of star formation, completely reshaping our previous understanding of galaxy formation. This revelation has the potential to revolutionize our comprehension of the cosmos. Recently, the astrophysical journal Letters has released the newly published work. According to Silk, the observation of distant galaxies from the early universe through the Webb telescope has exceeded scientists' predictions, as they appear significantly brighter and showcase an unexpectedly large presence of young stars and supermassive black holes. The commonly accepted belief is that black holes emerged following the collapse of supermassive stars, while galaxies formed once the first stars illuminated the ancient dark universe. However, the research conducted by Silk's team proposes a different scenario, indicating that black holes and galaxies existed simultaneously and had a mutual impact on each other's destiny in the initial 100 million years. To put it in perspective, if the entire timeline of the universe were condensed into a 12-month calendar, these years would be equivalent to the early days of January, according to Silk. Silk proposed the notion that the forceful emissions from black holes compressed gas clouds, causing them to transform into stars and expediting the process of star formation. Without this explanation, it becomes exceedingly difficult to fathom the origin of these luminous galaxies, as they tend to be more diminutive during the early stages of the universe. The question then arises, what could possibly account for their rapid production of stars? In the vast expanse of space, there exist regions known as black holes, where the gravitational force is incredibly intense, preventing anything, even light, from escaping their grasp. Within these gravitational powerhouses, magnetic fields of immense strength are generated, giving rise to tempestuous storms that expel turbulent plasma. In a remarkable display, these black holes function as colossal particle accelerators, according to Silk. Surprisingly, this phenomenon is the probable explanation for why Webb's detectors have detected a greater number of these black holes and radiant galaxies than scientists originally predicted. According to Silk, the existence of violent winds or jets in distant regions cannot be directly observed, but their presence is inferred from the abundance of black holes in the early universe. These colossal winds emanating from black holes exert immense pressure on surrounding gas clouds, triggering the formation of stars. This crucial connection elucidates the reason behind the unexpectedly heightened luminosity of the initial galaxies. According to Silk's team, the early universe can be divided into two distinct phases. In the initial phase, star formation was accelerated by the high-speed outflows emanating from black holes. However, in the subsequent phase, these outflows gradually decelerated. Roughly a few 100 million years after the Big Bang, the collapse of gas clouds was triggered by magnetic storms caused by supermassive black holes, leading to the birth of new stars at a significantly higher rate than what is observed in present-day galaxies. As time progressed, the formation of stars began to slow down as the powerful outflows transitioned into a state of energy conservation. This resulted in a reduction of available gas for star formation within galaxies. According to Silk, our initial assumption was that galaxies came into existence through the collapse of massive gas clouds. However, what caught us off guard was the discovery of a central seed within those clouds, a sizable black hole. This black hole played a pivotal role in expediting the formation of stars within the inner region of the cloud, surpassing our expectations in terms of speed. As a result, the first galaxies shine with an astonishing brightness. By utilizing the future observations of the Webb telescope, the team anticipates that their calculations will be validated, as they will provide more accurate data on the number of stars and supermassive black holes in the early stages of the universe. These forthcoming observations are also expected to assist scientists in uncovering additional evidence regarding the progression of the universe. He posed the significant inquiry: what were our origins? In the vast expanse of the Milky Way galaxy, consisting of 100 billion stars, the Sun is just one of them. Additionally, there exists a colossal black hole at its center. Is there a correlation between these two entities? Anticipating a wealth of enhanced information within the next year, he confidently stated that many of our inquiries will finally find resolution. Among the authors who have contributed to this work are Colin Norman and Rosemary F.G. Wise from Johns Hopkins, Mitchell C. Beagleman from the University of Colorado and the National Institute of Standards and Technology, as well as Adi Nusa from the Israel Institute of Technology. The team received support from the Israel Science Foundation and the Asher Space Research Institute, along with the endorsement of the Schmidt Futures program, courtesy of Eric and Wendy Schmidt. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.